Hi, in this video we will learn about sine ratio in trigonometry. As the name suggests, trigonometry refers to triangles, but basically those trigonometric ratios have a lot of use out of the triangles as well. We also use them in other 2D shapes and 3D shapes. So this is the start of what you're going to learn in IGCSE. So basically we have this right triangle and we have one of those angles, let's call this as alpha. Now it could be this angle or this angle, right? It doesn't matter which one, but according to the angle chosen or given, we name the sides of the right triangle like adjacent, and well, this is because this side is one of the arms of the angle. It's just beside the angle, so it's adjacent. And we call this side to be opposite. And as always, the longest side, which is across the right angle, is called as the hypotenuse. Right? If I was to choose this angle, right, let's call this as theta, right, then adjacent opposite would change. So according to this angle, the opposite side would be this, the adjacent side would be this, but the hypotenuse stays the same at all times. So let's start with an example. Right, let's write the names of the sides on these triangles. Remember, the names change according to which angle is given, right? So here in the first one, we are given angle alpha here. Alpha is a Greek letter in the alphabet, it's A. But we generally use Greek letters in trigonometry, but that's totally okay if you use something else. But alpha is here, so this must be adjacent because it's just beside the angle, it's the arm of the angle, and the angle across the side across the angle is opposite, right? And the side across 90-degree angle is hypotenuse, right? Now, in the second one, we are given the angle here at the top, so this must be adjacent. You can write an abbreviation ADJ, adjacent, and this right across the angle is called as opposite, as OPP, and the side across 90-degree angle is hypotenuse, so it's HYP, right? And in this one, right, you can start writing hypotenuse first if you'd like. This is the hypotenuse, it's right across 90-degree angle. Across the angle given, angle alpha is opposite, and so this is adjacent. And in this one, across the angle is opposite here. Beside the angle in the side is, say, adjacent. And of course, across the 90-degree angle is called as the hypotenuse. So the first thing we must do is we must write down those names so that we can just use the trigonometric ratios. Because the sine ratio is defined to be opposite of hypotenuse. So it's going to be like this: sine of alpha, this is the angle measure, equals opposite of hypotenuse. That's why we have this abbreviation. We have SOH. If you write them together, it is written as SOH. So we read this as SOH to remember that it's a sine equals opposite over hypotenuse, so it's called as SOH, right? And if I choose the sides according to the given angle alpha, this is the opposite, this is the adjacent, and this across the 90-degree angle is hypotenuse. Once I have them, all I need to do is to write down this side length over this side length. So this is the sine ratio. Let's work on an example. So the question is, given the triangle below, find the value of x. So this is the side length they're asking us. First of all, let's think about the names of sides. Across the given angle is opposite, beside the angle is adjacent, and across the 90-degree angle is hypotenuse. Now let's remember it was soh, meaning sine of the angle given, 38 degrees, is opposite is x, right, over hypotenuse, which is given to be 7. Now, first of all, before using a calculator, we have to leave x alone. You can see that x is divided by 7 here. So what we're going to do is we're going to multiply both sides by 7 and write down, because these will be cancelled out, x will be alone, right, isolated. X equals 7 sine 38 degrees. Now is the time to take a calculator and write the full sentence here, right? And you will find x to be 4.3096 and so on. Now generally, of course, the questions will tell you to what extent you're going to round the number. Let's say that's going to be for 3 significant figures, right? So I will be cutting my number from here. Now right before is 0, right after is 9, so I should be rounding this number to 4.31. Let me write it properly. 4.31 centimeters, right? So this is how you use the sine ratio to find the side length. Another example, right? So we have a different triangle here with different sizes, angles and lengths. So let's first write down the side names. Across the angle given is opposite. Beside the angle is adjacent, right? It's just beside the angle. And across the 90-degree angle is hypotenuse. And now this is the question. All right. So again, using this abbreviation, SOH, we are going to write down sine of, let's say sine, say 67 is given, 67 degrees, is, well, the opposite is 9.6 over hypotenuse, right, is the question, so it's x. Now, if you have the unknown, if you have x in the denominator, as in here, right, you can do cross multiplication, right? You can consider this as over 1, and you can do cross multiplication. But multiplying 9.6 with 1 will not change anything, so it's 9.6 here. And then you will have x times sine of 67 degrees, right? Now you have to leave x alone, so you have to divide both sides by sine 67 degrees, right? And then, of course, these will cancel each other out. You will have x to be 9.6 over, right, sine of 67 degrees. Now, look at this one. Let me clean this bit up. I'll just have these cleaned up. And let's take this here. Now, tell me what you can see. Can you see that sine and x just swapped places after all this work? So you don't need to do all the cross multiplication. What I'm saying is, if you have the unknown in the denominator and the trigonometric ratio here, you can just swap them. You can write x here, you can write the sine or whatever the ratio is in the denominator, all right? So once you have that, you can calculate x. So use your calculators to find x to be 10.429, and it goes up to infinity, right? And if this would be, let's say, 1 decimal place this time, you would cut it from here, and you will say x is approximately 10.4 centimeters. So that's how you find the side length. Now is your turn. Please draw these triangles on your book and solve for x values and submit your answers online. Now, you have to write your answers up to 1 decimal place for each value, right? Don't forget that. And please draw and name the side lengths before you start working on the question. Thanks for watching.